now we are in lesson number 9, solution. In this lesson we have discussed about what is solution, what are the types of solution, like that we have discussed. Now we are going to see solubility. What is solubility? Here in previous class we have discussed about saturated solution, isn't it? Only a particular amount of solid can be dissolved in a given amount of solvent. That is called saturated solution, we said. Okay, the same only here we are going to learn as solubility. Okay, the solubility is nothing but how much of solid can be dissolved in particular solvent, in particular amount of solvent. That is called solubility. Here two more question. Definition for solubility: number of grams of solute that can be dissolved in 100 grams of solvent to form a saturated solution. That is called what? Solubility. To form a saturated solution, that means no more solute can be added to the particular solution. Okay, such type of solutions are called as saturated solutions. To attain the saturation, how much of solute we have to add? Okay, that is called here solubility. How much we have to add? Okay, so here just for example, 36 gram of NaCl in 100 ml of water. Okay, 100 ml of water can consume only 36 gram of NaCl. Suppose if it is a calcium carbonate, means 100 ml of water can occupy, this can get 0.013 gram of calcium carbonate. Okay, this much of amount of solid can be dissolved in 100 gram of water. Okay, so the standard solvent amount is here 100 gram. Okay, 100 ml. So for NaCl it is 36 gram can be dissolved in 100 ml of water. For ammonia 48. For NaOH 80 gram. For sugar C6. For glucose C6H12O6. Okay, for glucose it is 91 gram. For sodium bromide NaBr 95 gram. For sodium iodide NaI it is 184 gram. Okay, one more question they can ask. Okay, so how much solute we can add to attain the saturation solution for sodium bromide or sodium hydroxide, like that they can ask. Okay, so names I will give you once again: calcium carbonate, CaCO3, calcium carbonate; NaCl, sodium chloride; NH3, ammonia; NaOH, sodium hydroxide. Okay, C6H12O6 is glucose. Okay, C6H12O6. Next, NaBr, sodium bromide. Okay, NaI, sodium iodide. Okay, so you must remember these values. Okay, one more question they can ask. So what is solubility? How much of solute can be dissolved in particular amount of solvent? The mass of the solvent is 100 ml of water. 100 ml of water, how much of solute of NaCl can be added into 100? This is the formula to find the solubility of the particular solution. Okay, so when they are asking in two more question to define solubility, you have to write the definition as well as this equation form. Okay, solubility is equal to mass of solute divided by mass of solvent into 100. Okay, children, yes, the next one here we are going to see what are the factors can affect the solubility. Okay, simply if we add the solute in the solvent, it will mingle, but some factors will increase or decrease the rate of the reaction. Okay, rate means speed of the particular reaction. Okay, the mixing. Okay, the mixing process will be affected. So what are the factors can affect? Here, first factor is nature of the solute and solvent. Okay, the nature of the solute and solvent, if both solute and solvent both are in liquid form, okay, then both will easily mingle. But both are polar compounds, means easily they will mingle. Okay, if you want to understand clearly, we can say aqueous and non-aqueous. In previous class we have discussed aqueous and non-aqueous. Some solute will dissolve in aqueous, that is water. Some solute will dissolve in carbon disulfide, ether, like that. Okay, so iodine cannot dissolve in water. Copper sulfate cannot dissolve in carbon disulfide. Okay, so chemists easily they will say like dissolves like. Okay, only polar compounds will dissolve in polar solvent. Non-polar compounds will dissolve in non-polar solvents. Okay, so there we have used the word aqueous. Here we are using the word polar. Okay, polar. Okay, NaCl, Na plus and Cl minus. Okay, plus and minus, two poles. Okay, so same it will dissolve in water. There is water also H plus and OH minus. Okay, two poles, plus and minus. So the polar compounds will dissolve in polar solvent like water. Okay, non-polar solvents, fat dissolves in ether. Example. Okay, so based on the nature of the solute and solvent, the solubility will be affected. Okay, so like dissolves like. Okay, polar compounds dissolves in polar solvent. Okay, so based on the nature, the solubility will be affected. Okay, that is the first point. Like dissolves like. Fat dissolves in ether. Fat is a non-polar compound. It dissolves in ether, which is non-polar. Okay, NaCl is a polar compound. NaCl, sodium chloride, the common salt. It will dissolve in water. Okay, so that is another example. NaCl in water. Okay, so nature of the solute can be affect the solubility. If you add NaCl ether, it won't be dissolved. If you add fat in water, it won't. Okay, so nature of the solute and solvent can affect the solubility. The next one here, temperature. How the temperature can affect the solubility? Maximum. Generally, when we increase the temperature, the solubility will increase. Okay, simply when we increase the temperature, two components will mix easily together, so that the reaction will be fast. So easily they will mingle with each other. But here, based on the temperature, again is classified into two types: endothermic reaction and exothermic reaction. Okay, endothermic, exothermic you have learned in your 9th standard, isn't it? Endothermic means the reaction which absorbs heat. Exothermic means the reaction which release heat. Okay, so it don't want to absorb the heat, it want to release heat. Okay, in such a condition, if you increase again if you are giving the temperature, means the reaction will be slow. Okay, it will become slow. But in the process of endothermic reaction, where really the heat is required, endothermic means what I said, it will absorb the heat energy. Okay, so really where it is needed, in such time if you are giving the temperature, means the reaction will be fast, the mixing with each other will be fast. Okay, so easily they will mix with each other. Okay, so based on the temperature, we can classify into two types. One is temperature is classified into two types. One is endothermic reaction and another one is exothermic reaction. Endothermic and exothermic. In endothermic reaction, heat is absorbed. Okay, heat is absorbed. In the exothermic reaction, heat is released. Okay, heat is released in this case. So in a particular reaction where heat is needed, in such a condition, when you are giving the temperature, when you are increasing the temperature, the solubility also will increase. Solubility also increase. In which condition it is? It is for endothermic reactions, where heat is absorbed, where heat is needed. Okay. For exothermic reaction, when you are increasing the temperature, the solubility will decrease. Why the solubility will decrease here? Why the solubility decreases here? Because already heat is released, and when the heat is released only, the reaction will take place further. In such a condition, you are giving heat, means the reaction will be slowed down. Okay, it will become slow. Okay, in such a condition, when you increase the temperature, solubility will decrease. Okay, you can understand. Endothermic reaction and exothermic reaction. Endothermic reaction, temperature increases, solubility also increases. For exothermic reaction, temperature increases, solubility exothermic reaction. Okay, this is for the solution in the form of solid in liquid. Okay, solid in liquid. For this type of solution, endothermic and exothermic reaction you have to remember, you have to write. Okay, suppose if you are preparing the solution that is gas in liquid. If you want to prepare such type of solution, here what is the role of temperature in such a case? Okay, in this case, actually gas we are going to fill in the water or any liquid. Okay, so when we are filling, we have to give high pressure there. We have to give pressure, then only we are able to fill the gas inside the particular liquid. Okay, in such a condition, if we are heating, if we are giving the temperature, means what the gas will do there? The gas will start to escape from there. Okay, when you are increasing temperature, the gas will expand and it will go out of the particular solvent. Okay, so in such a condition we should not heat. Okay, we have to decrease the temperature, then only we can add more amount of gas in the particular liquid solvent. Okay, so for prepare gas in liquid solution, the role of temperature is it should be decreased. We have to give less amount of temperature, then only solubility will increase. That's the aquatic species, aquatic animals mostly they will live in cold region. Okay, there only maximum amount of dissolved oxygen will present in the water. Okay, if temperature is more, means the oxygen will liberated from the particular water. Then there will be insufficient oxygen will be insufficient to take place, so they cannot breathe. Okay, so for that only they are living in cold region. Okay, in such a place more amount of oxygen will present in the water. Okay, so this is one 2-mark question, so mark it as a 2-mark question. When the temperature decreases, solubility increases. Where? In case of preparing gas in liquid, in such type of solution. Okay, children. So the next one here, pressure. How the factor pressure can affect the solubility. This is for preparing gas in liquid. Okay, in such solutions when we are prepare, the pressure will take place. Okay, where we are using gas as a solute or a solvent. In such a time we have to give high pressure. When we are giving more pressure, more amount of solute can be dissolved in a particular solvent. Okay, so simply we can say when pressure increases, solubility also increases. When pressure increases, solubility also increases. That's all. Okay, so now we will watch how the nature and temperature, pressure are affecting the solubility in the video now.
Factors affecting solubility. Why do aerated drink bottles open with a fizz? Well, in these drinks, carbon dioxide gas is dissolved in water under high pressure. When opened, all the compressed gas is released by the fizz. Let us learn more on the dissolution or solubility of substances in water. How does life underwater survive? Water is a liquid and living organisms require oxygen, which is a gas, for breathing. Then how do they sustain themselves? Oxygen from air gets dissolved in water, and some of it comes from the photosynthesis of the water plants. So, the extension of dissolution or solubility is an important factor for life. Solubility is the measure of the maximum amount of solute that can dissolve in a given amount of solvent at a given temperature or pressure. Factors that have an effect on solubility are the nature of the solute and solvent, temperature, and pressure. Observe this demonstration. What can you conclude from the experiment? Click on the appropriate words. Boiled water tastes bland because dissolved gases like oxygen and carbon dioxide have escaped from it. The quantity of solute dissolved is expressed in grams per liter. This means that if one can dissolve 30 grams of sodium chloride in 1 liter of water at 20 degrees Celsius, then the solubility of sodium chloride in water is 30 grams per liter.
Children, I hope you have all understood what is solubility, what are the factors can affect the solubility. Just go through this topic and write as a test and see the factors